Okay, here we are in example number 3. I always want to read through my given information as well as what I'm trying to prove and apply it to the picture before I even start the proof. So let's check it out. We've got angle NIO congruent to angle NGD. So let's find those two parts. Angle NIO, kind of nested in here, congruent to angle NGD. Okay, so we've got one set of congruent angles. We've also been given side NO is congruent to side ND. So side NO is this long side here, so we're talking about the whole thing, is congruent to side NG, or excuse me, ND here. Okay, so I've read my directions, I've read the given part, and I've drawn it into the picture. From here, we're asked to prove that an angle D is congruent to angle O. This is our task. All right, so let's check out our proof here. First, I'm asked to write out the two given pieces. So we're just going to rewrite these two in the blanks here. Angle NIO is congruent to angle NGD, and side NO is congruent to side ND. Now my third statement says that angle N is congruent to itself. Check out where angle N is. It's here in the corner. This is saying it's congruent to itself and nothing else. It's just congruent to itself. Thinking back to our previous example, example 2, we looked up what it meant for something to be congruent to itself, and that is the reflexive property of congruence. An angle can be congruent to itself. Okay? So when any time that something is congruent to itself, that is the reflexive property. And this is congruence because there is a congruent sign. All right, next on our list, we have that apparently this was enough information to prove these two triangles congruent. Let's take a look. I've got INO. Okay, INO, I think I'll outline in yellow. INO is congruent to GND. GND. So I have another set of overlapping triangles here. All right, so let's take a look. If I just look at the yellow triangle, let's just try to isolate that yellow triangle. If it's too hard to do, you could redraw it off to the side. The things we have marked in INO is angle I has a marking for one congruence. Angle N has a marking for a second congruence. And then side NO has a third marking for a congruent side. We can also redraw the orange triangle off to the side. Sometimes the overlap just kind of confuses the picture. So this is triangle DNG. We've got side DN has a congruent mark. Angle N has a double congruent mark. And angle G has a single congruent mark. So as I look at these triangles separated, I can see one of my 5 patterns of congruence. Okay, let's think back to our 5 patterns of congruence here. We've got SSS, SAS, ASA, AAS, and HL. Okay. HL is out on this one because we do not know that this is a right triangle. There was no mention of that. It looks like I've got 2 angles and a side marked, which leads me to either AAS or ASA. And due to the placement of that side, this is a non-included side. So these 2 triangles are congruent by AAS. Now, after we know that the two triangles are congruent, we can discern that every single matchup, every single corresponding part of the triangle has a match that's congruent. So I'm looking here in the congruent statement. I see angle D in the third position, and I see angle O in the third position. So I can decide that these two angles are also congruent because the entire triangle is congruent. And that's something very special. We use the abbreviation CPCTC. The congruent parts of congruent triangles are congruent. Okay, so anything that's a matchup now is a congruent pair. All right, in our next video, we're going to look at example number 4.